Hello. Today we'll be discussing the unit circle. This material isn't explicitly covered in the textbook. However, it is used very frequently in trig as well as any of the angles and common angles that will be used in the class. This is how you can memorize them and or construct them to best suit your purposes. So with that, we'll be talking about special triangles. As a previous video has reference to, we had a triangle that looked like this. We had an angle of 60 degrees, 90 degrees, and 30 degrees. Some of you may have seen this before and called this a 30, 60, 90 triangle. What is special about this triangle is the relations that the sides have. Specifically, if I have a side x here, this side, or the hypotenuse, is 2x. And the long leg of the triangle is x, square it, 3. Another special triangle is the isosceles right triangle, or it might be known as the 45, 45, 90. What that means is our angles are equivalent at 45 degrees. We have a right triangle, and if our angles are equivalent, and we're a right triangle, we have equivalent sides. So x is same, or I'll call it y, same as y, and so we have y square root 2 over here. Okay. So now, why am I making these? Because the unit circle can be constructed with help of these triangles. So we'll track our progress of the unit circle here. And our goal is to fill out the entirety of it. That looks pretty good. Okay, so what is the unit circle? The unit circle is a circle of radius 1. So we can think of this as x squared plus y squared equals 1. So our radius is 1, meaning that the point here, this is 1, 0. And if I think about that, I'm going to take another ray and I'm going to put it right here. I have an angle of 0. So this is 0 degrees. I'm going to write this in degrees. For your check on learning, I want you to follow this construction and write this in terms of radians. So you can follow the points and just convert the degrees to radians, and I'll be making most of those conversions for you. So I want to amend this and say that this is at 0 degrees. Okay. So what is the next one? The next major angle is here at 30 degrees. So we're here. What is this point on the rectangle or on the circle? Well, if we have radius 1, that means all of the hypotenuse of these triangles have radius or have a hypotenuse equal to 1. So if I make x equal to 1/2, I now have this 30, 60, 90 become 1 square root 2 or square root 3 over 2 and 1/2. That's what I have. Sorry, this is why I have a 60, but I could flip this and make it be a 30. So now I'm going to mark the short angle with this dash. This is 30 degrees, 30 degrees, and we have square root 3 over 2. We still have a radius or a hypotenuse of 1, and this is 1/2. And that kind of makes sense because even how I drew it here, it looks about to be 1/2. So we can label this point as square root 3 over 2, 1/2, and this is at 30 degrees. 30 degrees, if we transfer that into radians, that's pi over 6. Okay, well, we already have the other part of this, and we have another triangle here. And this one is 60 degrees, and so we have 1/2 and square root 3 over 2. So we have 1/2 square root 3 over 2, and this is at I'm going to write the at symbol for ease at 60 degrees, or 60 degrees is equivalent to pi over 3 radians. Okay, and now I'm going to work with this for a little while, and eventually we're going to get to this isosceles, but we're gonna play around with these triangles for a bit longer. So now imagine, if you will, that I take this triangle and I'm going to pick up this end while pinning down this side, and I'm going to flip it down here. So now my triangle looks something like that. Okay, well, what's this spot? Well, if we had a height of 1/2, and now we're underneath the axis by 1/2, we could label this as square root 3 over 2, negative 1/2. And this is at negative 30 degrees, which we could assign as pi over, or negative pi over 6. But we could also view this as we went around this way, and so this is actually 360 degrees, take away 30. So this is also 330 degrees. Now let's take this triangle and do the same thing. Plop it down here, and we get another point here, and let's label this as 1/2 negative square root 3 over 2, and this is at negative 60 degrees, or that's equivalent to 300 degrees. I'll let you guys make the radians adjustment yourself. Okay, so now I'm going to do the same thing. I'm going to pin the origin. I'm going to pick up this point, and I'm going to flip the triangle like this. And I'm going to get something that'll be equivalent, hopefully. It'll look something like that. And so now I still have the same height of 1/2. However, my distance here from the origin in the x direction is now negative. So I can think of this as negative square root 2, or square root 3 over 3. Negative square root 3 over 2, 1/2, that's the point. And this is at, and now where is this? Well, we're 30 degrees here. If this is 180, and we're going to take away 30 degrees. That means this is at 150 degrees. So here, I'm going to take 1/2, square root 3/2, and now I'm going to flip it, and we're going to get a triangle that looks something like this. And that's going to be at the point -1/2, square root 3/2. And this is going to be at, we can think of this as 180, take away 60, that is 120 degrees. Well, 120 is double 60, so if this was pi/3, this guy is 2pi/3. All right. Well, now let's look at the top. Well, at the very top, we have 0, 1, and this is at 90 degrees, or pi/4. And that makes sense because we have a radius of 1. We have no x. And so this is where we don't really have a triangle here at all, but we can picture it, exactly what that would be. So over here, we have -1, 0. And this is at 180 degrees. Well, let's follow this around. We're again going to pick up this point, put it down here, and we get a negative height and a negative distance from the origin from with respect to x. So we're going to have negative square root 3/2. That doesn't change. But now we have a -1/2. And this is at, we have 180 plus another 30. So we're going to say that this is 210 degrees. That's this point here. So now I take this and I flip it down. And I'm going to have a -1/2, a negative square root 3/2. And this is at, I have 180. I'm going to add 60. So this is at 240 degrees. That's what that point is. Point down here is 0, -1. And this is at, we can think of this as 180 plus 90. We could also think of this as 360 minus 90. And we get 270 degrees. We could also reference this as 3pi/2, because this was pi/2, 2pi/2, 3pi/2, and if we have 4pi/2, well, that's same as 2pi. In fact, we can all say that this is equivalent to 360 degrees for the 1, 0 point. Okay, so now we have something that is in reference to all of these points on the unit circle, and all that we used was the 30, 60, 90 triangle. And now I want to use the other one. So when I take a look at this equation, I'm going to see if there's a different color chalk. No. Yeah, I'm going to erase these lines for clarity, but keep track of them Now pause the video if you need to. I'm just going to trace the inside of this unit circle. Okay. So how can we make this 45, 45, 90 onto the unit circle? Well, we need a radius of 1 to be on the unit circle. So we need a hypotenuse of 1. So we want to have y be equal to 1 over square root 2. We rationalize the denominator, we get square root 2 over 2. So this is square root 2 over 2. And then here we have square root 2 divided by square root 2. So this is just 1. So if we have a 45-degree angle, here we have square root 2 over 2, square root 2 over 2, and this is at 45 degrees, or we can label this as pi over 4 radians. We pick this triangle up, we place it over here, and we do the exact same thing. And so here we have negative square root 2 over 2, square root 2 over 2. This is at 45 plus 45 plus 45. We could also think of this as 180 minus 45. That is 135 degrees. We can also think of this as 3 pi over 4 radians. Here, we're going to take this down, and that's as if we took this triangle and flipped it down like this, and we get negative square root 2 over 2, negative square root 2 over 2 as our point. This is at 225 degrees, or in radians, this would be 5 pi over 4, because here we're at 4 pi over 4 plus 1/4 pi. And then finally, we can complete the unit circle and mark down this as positive square root 2 over 2, negative square root 2 over 2 as our coordinates, and this is at 285 degrees, or we can think of this as 6 pi over, not 6 pi, here's 6 pi over 4, 7 pi over 4, or 100, I think I messed this up. 360 minus 45, that is 315. Yeah. I don't know what I was thinking there. I had a brain fart. Okay. So this is the completed unit circle. And all that we used were the special right triangles. So if you want to go through and recreate this from scratch, do so. That'll help out a lot with knowing the sines and cosines. I'm going to talk about that briefly for the end of the video. And for the check-in learning, remember to make this unit circle, but in regards to radians, degrees. Okay. So why the heck do we want to know this? Well, if we think about sine and cosine, we get those for free here. If we know this, if you on a test, the first thing that you do, you take out the test and you write down this unit circle, every sine and cosine that has these common angles, you will get automatically. Why? Well, that's simply because x equals cosine of theta. So if you put, when we have the unit circle, our x coordinate is what the theta is. So cosine of 0, 1. Cosine of pi over 2, that is 0. Cosine of pi over 4, square root 2 over 2. Cosine of 300 degrees, well, that is square root 2, because I can find it right here. It's the x coordinate of these points. Okay. Well, y is equal to the sine coordinate of these points. And that shouldn't be too terribly surprising because, one, sines and cosines go together often enough, but we can see that sine of like 45 degrees is square root 2 over 2. Sine of 60 degrees, or pi over 3, that is square root 3 over 2. However, if we forget this fact, we can reclaim it because remember, these are triangles. If I look at this triangle here, and I want to take the sine of this angle, so this angle I'm going to note as negative 30 degrees, well, it's the opposite over hypotenuse. Oh, sorry, this is the angle of negative 45 degrees, or 315. It's the opposite over hypotenuse, and I get opposite square root 2 over 2, and the hypotenuse is always 1. So negative square root 2 over 2, divide by 1, negative square root 2 over 2. And we found in a previous video that tangent is equal to sine theta divided by cosine of theta, which is equal to, by this convention, we have y divided by x. Meaning, I now know tangent of 45 degrees. That's square root 2 over 2 divided by square root 2 over 2. That's 1. Here, I can do what's tangent of 170 degrees. Well, that's 0 divided by negative 1. That's 0. Well, what about tangent of, oh, sorry, I messed this up. I meant to say this in reverse. Tangent of 0, negative 1, or tangent of 270 degrees is undefined because we have negative 1 divided by 0. So it's undefined. Blows up to infinity. Here, we have 180, tangent of 180, that's 0 because we have 0 divided by negative 1 because we have y divided by x, the y coordinate divided by the x coordinate. So we can check our work and we can find out what tangent, sine, cosine is quite easily. Well, now knowing these relations, we can start figuring out what cosecant is, what cotangent is, what secant is. So we have secant of theta. What is secant? Oh, it's 1 over cosine. 1 over cosine is really just 1 over x in this case. And we have cosecant of theta is equal to, here, cosecant is 1 over sine. So what's 1 over sine? Well, that's 1 over y. And cotangent of a theta is equal to we're going to take the reciprocal, or 1 over tangent. This is tangent of theta. And so we get x divided by y. So with this, we now have a way of finding cotangent, tangent, sine, cosine, any of these without a calculator. Now, you're allowed calculators for the most part, if not for all of them in the course, depending on if this video is in for later sessions, for like depending on course instructor. However, being able to do these things quickly is a really, really valuable skill. Also is a good way to check your work, because not always are we going to want an approximated answer. There will be times where we want an exact answer. And so if you say that, okay, square root of, or cosine of pi over 4, and you give the decimal expansion of square root 2 over 2, that's not going to be correct. We want the exact answer, and now you can provide it. It's square root 2 over 2. So as a reminder, the check-in homework is to make this unit circle, except the only exception is have radians here. So an example would be to have, like here, we have square root 2 over 2, square root 2 over 2 at pi over 4. Okay. I want them all listed out between values of 0 and 2 pi. So don't label this negative pi over 6. Label it as the appropriate pi over 6, which would be 11 pi over 6. And this is the last video for the week. So when you are done with that check-in, compile all the other check-ins for the week, submit them as a PDF document to the online quiz. Thank you for watching and have a great day.